All right, so now that we have set up our hypothesis test question, how we're going to answer it. Now, this is where the complications come in. Okay, first of all, let me tell you, this is something that really generates a lot of philosophical difficulties. Just to tell you a few things about it, this is a method which is barely more than 100 years old. Okay, so even though we think of a lot of these statistical methods as being very old, going back to the ancient Greeks, just like that statue, but no, it is not. This is a method that is very, very recent. In fact, it is a method that some people, some statisticians and some researchers don't like. In fact, many statisticians and researchers these days are moving away from a hypothesis testing method for a number of reasons that we will identify as we look at it more in depth, and we're moving toward more sophisticated, more advanced, more convincing ways of answering the question. Okay, but this is a basic method, one that is still used very extensively in the health literature, and so you definitely want to know about this one before you move on to anything else. You want to look at it with an open mind. Okay, so keep your mind open, not so open that you're going to let everything else fall off, but keep an open mind. There are limitations, there are difficulties, there are things that are not very convincing. We're going to have to live with that. Remember, in statistics, nothing is black and white, everything is gray. We're going to answer this question by using a probability type of argument. Therefore, if you're a little bit unfamiliar or you've forgotten about probabilities, you may want to review what we said about them in the previous classes. And finally, and probably this is going to be the most useful thing for you, is we're going to use an argument that mimics what people do in the court system. Let me explain what that means. The court analogy is a very common analogy. It's not my own idea, but it is used very commonly to explain how the hypothesis testing method works. In fact, this probably was one of the motivations for developing the system in the first place. Okay, so we're going to compare what happens in court and what happens in hypothesis testing. In court, when someone is taken to trial, the court assumes, or the authorities assume, that the person who is brought to trial is innocent. Well, in hypothesis testing, we're going to start by assuming that there is an equality. And again, this may be a little bit fuzzy to you at the moment because we haven't seen too many examples, but it will become hopefully clearer later. So we're going to assume that a certain equality exists. Some parameter is equal to something, to a certain value, or maybe two parameters are equal, or one parameter is equal in two different populations. But in either way, there is an equality. In the court then, evidence is collected by the police, by the defendants, and whatever. In hypothesis testing, of course, we're going to collect data. In the court system, we ask the question, or the courts ask the question, does the evidence indicate guilty? Okay, does the evidence convince everyone that in fact the person is not innocent but is in fact guilty? In the same way, in hypothesis testing, we say, do the data indicate that in fact there is the inequality that we suspect? Okay, so does it support that that assumption of the inequality, not the equality that we started from by a different thing? Okay. In the court system also, once all this is analyzed, people arrive at a conclusion, at a verdict, either guilty or innocent. In the same way, in hypothesis testing, we're going to arrive at a conclusion, either that the inequality seems to exist, or that we don't have any evidence for it, or not enough evidence for it. But keep in mind that just as in the court system, we need to be open to appeals when new evidence comes about, or if some things have not been analyzed properly. In the same way, in hypothesis testing, we have to be open to what more data may provide us. So the conclusions are never definitive. Conclusions are always subject to new evidence, and the conclusions always provide evidence but not a definitive answer. Let's go back to the example of the jumping jacks and the knee bends to see how all this comes about. Okay, so we're going to start by assuming innocence. Who's innocent here? We're not in the court system. We're talking about statistics. All right. So we're going to assume the equality. What does it mean? We're going to assume that the mean heart rate for the jumping jack situation is going to be exactly the same as the mean heart rate for the knee bend situation. That's the hypothesis of innocence, of being the same. Okay. Then we're going to collect a sample. Let's say we collected a sample and we found these pieces of information. So we find that in the sample that did jumping jacks, the mean heart rate was 24.5. In the sample that did the knee bends, the mean heart rate was 21.8. We can see that in the sample, the mean heart rate for the jumping jack is indeed higher than the one for knee bends. Okay. So the sample data support the claim that in fact jumping jacks are more strenuous, so they go against the assumption of equality. But, and this is a big but, really the thing, I shouldn't have said that, should I? But this is really the point where the rest of the complications come in. The point is, could this difference that we have observed in the sample could it have happened by chance? Okay, remember that we're dealing with random variability, and therefore what we have seen could have occurred just by chance. This particular group could have in fact been could have revealed a higher heart rate for jumping jacks just by chance because that particular sample reacted that way. Okay. Or is that difference actually true in the whole population? And that is the $6 million question that we'll have to address.